Let's apply our understanding of tangent lines and circles to go ahead and solve this problem together. So we have this marble that has a radius of r and is going to be rolling along a L-shaped track. The question is how far is the center of the marble from the corner of the track? This right here is the center of the circle that they are referring to, and the corner of this L-shaped track they're referring to as well is going to be right over here. They're basically just asking us what the distance is between these 2 points. To hopefully make this problem a little bit more clear and easier to understand, I'm going to go ahead and rotate it a little bit and then throw it on the coordinate plane. Alright, so let's see. Here is our coordinate plane. And let's go ahead and take our image here. And let's go ahead and rotate it and throw it onto the coordinate plane. So here is our diagram rotated and put on the coordinate plane. We do still have the center of this circle right over here, and we're going to try to find the distance between that and this origin here, or the corner of that L. This right here is the distance that we are looking for. And let's go ahead and label the center of the circle with the coordinates x, y. Now let's think outside the box or outside the circle a little bit here and see if we can find the value of x, which is going to be the distance in the horizontal direction that the center is from the origin, right? So how long is this distance right over here? Well, keep in mind that this horizontal distance matches this horizontal distance right over here, and this is the radius of the circle. That being said, we can go ahead and say that this x value, or x coordinate, is going to be the same thing as the radius length. Now what about y? Well, y is going to be the vertical distance of the center from the origin. So if you go from the origin and you move up this distance right over here, keep in mind that that's going to be the same distance as from here to here, which is also going to be the radius of the circle. So we can see here that y's value is also going to be r. So this distance is going to be r, and this distance is also going to be r. If you go ahead and take a look at this image right over here, I'm going to go ahead and recreate this on the side. So it looks like we have a square with the dimension of r by r. And here's the diagonal distance that we're going to be solving for. That's going to be the distance between the center of the circle and the corner of the L. Now, because this is a square, keep in mind that this is going to be a right angle, but also if we have the diagonal of a square here, that means this diagonal line is essentially going to be bisecting a 90-degree angle. So each of these must be 45 degrees, and we have this 45, 45, 90 right triangle. Now, if you remember our special right triangles and you remember that 45, 45, 90 special ratio here, you might remember that this d value then must have to be this r root 2. So r multiplied by the square root of 2. And that's just because we have a 1 to 1 to root 2 ratio with all 45, 45, 90 triangles. But if you didn't remember that, that is okay. You can also go ahead and use the Pythagorean theorem to go ahead and calculate this, right? So we know that these are the two legs of r and r. So if we go ahead and use Pythagorean theorem, we can say r raised to the second power plus this other r raised to the second power. That would be equal to the distance of the diagonal, or the hypotenuse, raised to the second power as well. All right. Now, if you go ahead and square r and add those together, we're really looking at this is going to be 2r to the second power. And that's going to be equal to the distance on the diagonal squared. And if you go ahead and take the square root of both sides here, if you go and take the square root of the right side and take the square root of the left side, you're going to see here that on the right side, we're just going to have the distance, all right? And then on the left side, the square root of r squared is just going to be r. And then we're also just going to have the square root of 2 because that's not a perfect square. And so we just solve for d, which is going to be the hypotenuse of this right triangle. You can see that's going to be the distance between the center of the circle and the corner of that L, which is really just what we have from here to here. This right here would be our answer.